Hello, and welcome to subtopic 4.2 Covalent Bonds. Let's share. We're going to do this in two parts, and this is part one. Molecules, what are they? Well, it's pretty simple. Any group of covalently bonded atoms is a molecule, such as nitrogen gas and water. So just what is a covalent bond? Well, let's illustrate it with two hydrogen atoms. They each have a valence electron, and they decide to share their valence electrons. The shared pair of electrons makes a single covalent bond. There can also be double covalent bonds, such as in oxygen gas, where there are two shared pairs of electrons, making a double bond, and nitrogen gas, which has three shared pairs of electrons, making a triple bond. Strong covalent bonds are shorter than weak covalent bonds. Double bonds are shorter and stronger than single bonds, and triple bonds are shorter and stronger still. This chart from your book illustrates it well. The carbon-carbon single bond in ethane has its own bond length and bond strength, and the carbon-carbon double bond in ethene is shorter and stronger. The carbon-carbon triple bond in ethine is the shortest and strongest of all three of these examples. If the electron pair in a covalent bond comes from just one atom, we call that a dative bond. For example, here in carbon monoxide, one of the triple bonds, the electrons came from just oxygen. Another example of a dative bond comes from hydronium ion, which is formed from water and hydrogen ion. We'll see this a lot in acid-base chemistry. Remember that in ionic compounds, no electron is shared, though it may be transferred because the difference in electronegativity between the atoms is so large. If we make a covalent bond between atoms of the same element, the electrons are equally shared because obviously they have the same electronegativity. This is called a non-polar covalent bond. When we form a covalent bond between two atoms with different electronegativities, we end up with what is called a polar covalent bond, because the electrons are pulled closer to the more electronegative nuclei. We can denote this with a lowercase delta, which indicates that we have a fractional charge at both ends of the resulting molecule. We can also denote this with a simple arrow on the bond line pointing towards the more electronegative nuclei. We can summarize the last three slides in this table. At one end, we have ionic bonds, which result from a great enough difference in electronegativity between the participating nuclei. At the other end, we have non-polar covalent bonds, which is what happens when there's no or maybe just a small difference in electronegativity. In between, there's a range of polar covalent bonds, which happen with the in-between differences in electronegativity. That's it. Thank you. Keep your eyes open for part two.